Okay guys, so today we're just continuing off from where we left off yesterday. So we're still in 3.1 notes, alright, and we're starting off from example 6 where we left off. So example 6, n plus 11 less than 13. And it's just like I told you, whenever we have an inequality symbol, we still do everything exactly the same way, just as if there was an equal sign there. So my goal is still to get the variable by itself, but I need to get rid of that negative 11, or that positive 11, so what do I do to the positive 11? I subtract 11, I take the opposite. So what's positive 11 minus 11? 0, which is what I want. So I have n left on the left-hand side. That less than symbol stays. And 13 minus 11? 2. So n less than 2 is my solution. Now what is that telling me? That's telling me that I can pick any n, and as long as it's less than 2, it will make the original statement true. So how do we check it? We pick a number that's less than 2. And I always like to pick either 1 less than or 1 greater than, depending on the symbol, so that we're as close to 2 as we possibly can. So since this is n less than 2, I'm going to pick 1. So instead of n, I'm going to plug in 1 plus 11 less than 13, because the answer has to be any n that's less than 2, right? 1 is the next closest number that's less than 2.
So it could be like negative...
It could be negative 500 if you want. But we want to get as close, I like to get as close to 2 as possible. So just to make sure in case we made some kind of calculation error. Okay, so 1 plus 11 gives me 12 less than 13. Is 12 less than 13 a true statement? Yep, so we got the correct answer. Okay? Is this helping you more now than yesterday?
If greater than, if the sign is greater than or equal to, we could have the answer, we could like have 2 or...
Yes, if the symbol was less than or equal to, you could have plugged in 2 in to check, because n can equal 2. Yeah, that's exactly right. Okay, so example number 7. Let me erase that less than just in case. Okay, negative 23 plus k greater than or equal to negative 14. So this is exactly what you were talking about. So my goal is still to get the variable by itself. So I need to get rid of that negative 23. How do I get rid of negative 23? Add 23 to both sides. Negative 23 plus 23. 0. So I'm left with k greater than or equal to negative 14 plus 23. What do I get there? Net positive 9. So k greater than or equal to positive 9. Any k that's greater than or equal to positive 9 will make my original statement true. So let's do a check. What can I plug in to check this one?
9.
Can I plug in 9?
Mm-hmm.
Yeah, because k can equal 9, right? Because of that greater than or equal to. So I'm going to plug in negative 23 plus 9 greater than or equal to negative 14. Negative 23 plus 9, that's going to give us a negative 14 greater than or equal to negative 14. Is that a true statement? Yes, it is. So we got the correct answer. Make sense? Okay. So example number 8, word problem. 22 cents plus the cost of 1 donut equals 89 cents. What is the cost of 1 donut? So first we have to translate this. What do you want to make the cost of a donut? How about D equals the cost of 1 donut? We always, whenever we're introducing a variable, we always need to label what it is. Okay, so we need to identify, okay, I'm going to start using D, and D is the cost of a donut. Okay, so let's translate this. 22 cents plus, so what am I going to have? 22 plus the cost of one donut. What's the cost of one donut? D. And we know that 22 cents plus the cost of one donut equals what? 89 cents. So 22 plus D equals 89. I want to get D by itself, so what am I going to do? I'm going to subtract 22 from both sides, because positive 22 minus 22 gives me a big fat 0. So I'm left with D equals 89 minus 22. That's going to give me 67. So the cost of one donut is 67 cents. Oops. Okay? Can we check it? Let's check it. 22 plus 67, and we want that to equal 89. Okay, 22 plus 67. 2 plus 7 gives me 9. 2 plus 6 gives me 8. 89 equals 89. Is that a true statement?
Yeah.
Yes, it is. So 67 cents is the correct answer. Okay, so what we're going to be doing now is, now that we're comfortable with solving these, we're going to solve and then graph our solution. So example number 9. Your instructions are to solve and graph on a number line. So the equation that we want to solve is x plus 7 equals 4. And then we're going to graph that answer, whatever it is, on a number line. Okay, so the first thing we're going to do is we're just going to solve this like we have already been doing. So I have x plus 7 equals 4. So x plus 7 equals 4. I want to get x by itself, so what do I have to do? Minus 7 from both sides. 7 minus 7, what does that give me? 0. So on the left-hand side, I am left with x equals 4 minus 7. Negative 3. So that's my answer. X equals negative 3. How do I plot that on the number line? I just put a point at negative 3. Yeah. Alright, so example 10. 6 plus p less than or equal to negative 1. Alright, so 6 plus p less than or equal to negative 1. I want to get p by itself. So I'm going to subtract 6 from both sides because this is a positive 6. Positive 6 minus 6 gives me 0, so those cancel. So I have p less than or equal to negative 1 minus 6. What's that? Negative 7. So p less than or equal to negative 7. So I want to represent this on a number line. Is my dot going to be open or closed?
Open.
Less than or equal to, it's going to be closed. We can equal negative 7. So we're going to put a closed dot at negative 7. And we are less than or equal to. So is my arrow going to go to the left or to the right? Less than or equal to, so it's all numbers less than negative 7. Okay, example 11. K plus negative 14 greater than or equal to positive 15. Okay, so for this problem, the first thing I want to do is I want to simplify that left-hand side. This left-hand side is not as simplified as it can be, right? If I have plus negative, that's the same as k minus 14 greater than or equal to 15. Because adding a negative is the same as just plain subtraction. Now what are we going to do? To get rid of that negative 14, we're going to add 14 to both sides. And I ran out of room, so I'm going to bring it up here. So negative 14 plus 14 is 0. So on the left-hand side, we're left with k greater than or equal to 15 plus 14, positive 29. Okay, so I want to graph this. I have greater than or equal to, so is my dot going to be open or closed? Closed, because we can equal the 29. And greater than or equal to, so am I going to the right or to the left? The right, because I'm getting bigger, so my arrow is pointing to the right. Very good. All right. Last one, example 12. Okay, negative 26 equals W minus negative 3. I want to solve that and graph it. So what do I need to do first here? First, I need to simplify that right-hand side. It's not simplified all the way. I have minus and negative, so what happens? It all becomes positive. So this changes to negative 26 equals W plus 3. So then we want to solve for W, so I have plus 3 over here. So to solve for W, I'm going to subtract 3 from both sides. Positive 3 minus 3, that gives me 0. So I'm left with, and I ran out of room again. So I'm left with what on the left-hand side? Negative 26 minus 3. That's going to be negative 29 equals W. Which means it's just going to be a closed dot, right? So a closed dot at negative 29. And that's it.